Hi learners! Welcome to Math is Fun with Sir O. Today, I will be discussing graph theory. In today's lesson, we're going to discuss the different kinds of graphs, Euler circuit, and Eulerian graph. Now let's go to our learning outcomes. At the end of this lesson, the learners will be able to first, familiarize the different types of graphs. Second, learn the origin of graph theory. Third, know what an Euler circuit is. Fourth, familiarize the Eulerian graph theorem. And lastly, apply Euler circuit in real-life situation. The history of graph theory. We're going to know the origin of graph theory. The basic idea of graphs were first introduced in the 18th century by Swiss mathematician Leonhard Euler. His attempts and eventual solution to the famous Königsberg Bridge problem depicted on the picture are commonly quoted as origin of graph theory. The German city of Königsberg, present day it is Kaliningrad, Russia, is situated on the Prigolia River. The geographical layout is composed of 4 main bodies of land connected by a total of 7 bridges. Euler, recognizing that the relevant constraints were the 4 bodies of land and the 7 bridges, drew out the first known visual representation of a modern graph. A modern graph, as seen on the picture, is represented by a set of points known as vertices or nodes, that connected by a set of connecting lines known as edges. By first attempting to draw paths in the graph, then later experimenting with multiple theoretical graphs with alternating number of vertices and edges, he eventually extrapolated a general rule. In order to be able to walk in an Euler path, also known as without repeating an edge, a graph can have none or 2 number of nodes. From there, the branch of math known as graph theory lay dormant for decades. In modern times, however, its application is finally exploding. In 1736, Euler proved it is impossible to walk such a path. His analysis of the challenge laid the groundwork for a branch of mathematics known as graph theory. It took 200 years before the first book on graph theory was written. Graph theory has developed into an extensive and popular branch of mathematics which has been applied to many problems in mathematics, computer science, and other scientific and not so scientific areas. Introduction to graphs. Think of all the various connections we experience in our lives. For instance, friends are connected on Facebook, cities are connected by roads, computers are connected across the internet. A branch of mathematics called graph theory illustrates and analyzes connections such as these. For example, the diagram could represent friends that are connected on Facebook. Each dot represents a person, and a line segment connecting 2 dots means that those 2 people are friends on Facebook. This type of diagram is called a graph. What is a graph? A graph is a set of points called vertices and line segments or curves called edges. In the picture, the colorful dots or points are our vertices, and the line segments that connecting all the points are our edges. 2 vertices are adjacent if they have a common edge. So for example, if this vertex and this vertex are joined with this one common edge, then we can say that the 2 vertices are said to be adjacent. 2 edges are adjacent if they share a common vertex. For example, this edge here and this edge here share a common vertex, this one. And so they said to be adjacent edges. A loop is an edge, the endpoints of which are the same vertex. So this one here is a loop, since both of the endpoints of this edge is connected to only one vertex. Different kinds of graph. This graph is not connected. It consists of two different sections. It also contains a loop. Thus, its name is disconnected graph. Null graph. It is a graph in which no edge is drawn between any two vertices. This graph has 5 vertices but no edges. It is also called an example of a disconnected graph. So meaning if you have only your points, then that is still considered a graph, but then it will fall onto the name which is null graph. Simple graph. It is a graph that does not have more than one edge between any two vertices and no edge starts and ends at the same vertex. As you can see on the picture, each of the vertex there share only one common edge attached to them. In other words, a simple graph is a graph without loops and multiple edges. This graph has multiple edges. It has also a loop. That's why it's called not a simple graph. Complete graph. It is a graph in which every possible edge is drawn between the vertices. On the picture, these are our complete graphs because we're able to draw possible edge between our vertices. Bipartite graph. A graph is bipartite if it is possible to divide all its vertices into two disjoint subsets, such that every edge in the graph connects a vertex in one subset to a vertex in other subset. Can you still recall our lesson on relations and functions, where we're able to graph our two values, the x and y? In our example here, we have our values of u and v, then we are connecting them or mapping them with our line segments. Directed graph. It is a graph where all the edges are directed from one vertex to another. In directed graph, we'll be able to know which point are we going to go next. From point A, it says there that we're going to point B, then we're going to point C, going to point E. Then in point E, we have two possible points that we're going to. So you can go to point F, and then you can go to point D. So if you choose to go to point D, then from point D, you can go back to point B. A directed graph is sometimes called a digraph or directed network. Tree graph. A tree graph is an undirected graph in which any two vertices are connected by exactly one path, or equivalently, a connected acyclic undirected graph. Equivalent graphs. Two or more graphs are equivalent if the edges form the same connections of vertices. Are these graphs equivalents? So if we're going to examine here, on the first graph, starting with our vertex 1, it is connected to vertex 2 and vertex 4. On the second graph, also starting with vertex 1, it is also connected to vertex 2 and vertex 4. On the third graph, so on the vertex 1, it is also connected to vertex 2 and vertex 4. All we need to do is we're going to examine all the vertices, and if we found out that all the vertices have the same connections among the vertices, then we can say that they are equivalent graph. So let's have another example. Are the two graphs above equivalent? You can pause this video if you need more time to examine our graphs. For our solution, the edges are AC, AE, BD, BE, CE, and DE. The edges of the two graphs represent the same connections. Despite the fact that the two graphs have different arrangements of vertices and edges, Thus, the graphs are equivalent. What is a path? A path is any route along the edges of a graph. A path may follow a single edge directly between two vertices, or it may follow multiple edges through multiple vertices. If a path ends at the same vertex at which it started, it is considered a closed path or circuit. So meaning, if your path is open, then it is only a path. But then, if it started and ended at the same point, then that path is considered a circuit. Trace a closed path in the graph on the right. So we have here our path. We're going to follow this path. So from point A, we go to point D, point F, point G, point H, point E, point C, point B, and goes back to point A. So thus, this is a closed path or a circuit. Euler circuit and Eulerian graph. An Euler path is a path that uses every edge of a graph exactly once. An Euler path starts and ends at different vertices. An Euler circuit is a circuit that uses every edge of a graph exactly once. An Euler circuit starts and ends at the same vertex. This time, we're going to know the degree of our vertices. Say, for example, this graph. If we're going to see, we have two edges connected to this vertex, and thus, the degree of this vertex is equal to 2. In this vertex, we have 4 number of edges connected to it, and thus, we can say that the degree of this vertex is 4. So in order for us to know the degree of the vertex, we're going to count the number of edges connected to it. Now, any graph that has even degree at every vertex must have an Euler circuit. So we will have an Euler circuit if the degrees of our vertices there are all even. A graph that has an Euler circuit is called Eulerian. So if we find out that our graph is an Euler circuit, then we can call that graph is an Eulerian graph. Which of the graph above is an Eulerian graph? By examination, on the first graph, the degrees of the vertices there are all even. On the second graph, we have some of the vertices that are odd. Thus, our graph number 1 there is an Eulerian graph. Eulerian graph theorem. It states that a connected graph is Eulerian if and only if every vertex of the graph is of even degree. Determine whether the graph on the side is Eulerian or not. So by examination, all of the vertices there are all of even degrees. Thus, we can say that this is an Eulerian graph since it has an Euler circuit and all the vertices there are all even degrees. Check your progress. So I have here 3 questions. All you need to do is answer and explain briefly. So this will be considered as your assignment for this lesson. Thank you so much for listening and watching this video. Please don't forget to like and share this to your friends and your classmates. And if you have questions, just go to the comment section below. And I hope you consider subscribing to this YouTube channel. Again, it's my pleasure to create and make video on your math lessons to make your learning journey a wholesome and fun activity. By the way, this is your Sir O. Till next time, God bless and keep safe always. Goodbye.